Okay, so in this video I'm going to have a look at deriving Heron's formula for finding the area of a triangle, where you know the lengths of the sides of your triangle. So you have the three sides. So the formula just says that if you have the three lengths here, A, B, and C, you can let another letter, let's say S, equal to A plus B plus C. So you add the three lengths and divide by 2. That'll give you this letter S. That would just give you the area then of the triangle. The area of our triangle is just going to be equal to the square root of S times S minus B times S minus A times S minus C. So this is Heron's formula here. So we're going to derive this. Okay, so let's start. Now we have our triangle here with height h and side lengths a, b, and c. First thing we're going to do is just have a look at finding what h is in terms of a, b, and c. So what we're going to do first is just take the triangle on the left first. And what I'm going to do is just call this distance here, let's say x from here to here. And therefore this distance over here then, so the distance from here to here is x, so this distance here must be c minus x. So that's the distance from here to here. The base of this right angle triangle on the right is c minus x. The base of this triangle here on the left is just x. So let's have a look at our triangle on the left here. The triangle on the left here, we can apply, because it's a right angle triangle, we can apply Pythagoras Theorem. So we have x squared plus h squared is going to give us a squared. The triangle on the right then, we can say c minus x squared plus h squared is equal to b squared. So we have two formulae here, both with two variables. We have an x and a h in here. We have an x and a h in here on the left as well. So we need to try to get h in terms of a, b, and c using these two formula. Well, let's just have a look at this one here first. So we're going to say h squared here is just going to be equal to a squared minus x squared. Subtract x squared from both sides. And what I'm going to do now is just substitute this here in here. So let's come over here then. So we end up with c minus x squared plus our h squared. Now our h squared is just a squared minus x squared from this equation over here on the left. And that's just equal to b squared. Okay, now, so let's just expand this here on the left. We have c squared minus 2cx plus x squared plus a squared minus x squared is equal to b squared. Now you can see here that we have a plus x squared and a minus x squared. That will give us 0. And I have a c squared here. I have an a squared, so I'm just going to put that down here. And I'm going to take this minus 2cx and bring it over to the right-hand side. So I'm going to add 2cx to both sides. So I end up with b squared plus 2cx. So c squared plus a squared is b squared plus 2cx. Now I want to solve for x here. So I'm going to take a c squared plus a squared. I'm going to subtract b squared from both sides. It'll give me 2cx here on this side. And then finally, I'm just going to take the c squared plus a squared minus b squared. I'm going to divide both sides by 2c. That'll give me 2c on this side here. Okay, so now I have x in terms of a, b, and c here. So if we come back up here now to this equation up here, you'll see that we can substitute x in here to find h. So let's do that. So we have h squared is equal to a squared minus x squared. We can put in here h squared is equal to a squared minus a squared minus the square of this here. So it's going to be c squared plus a squared minus b squared over 2c. And this all has to be squared because this is x here, so we've got to square it. This is our h squared. We're looking for h, so you've got to square root all of this. So our h then is just simply going to be a squared minus c squared plus a squared minus b squared all over 2c, and we've got to square that. So now we have our h in terms of a, b, and c. Okay, so let's just look at the next step then. We had our original, let me just go back up here to our original diagram here. We have our original diagram here, which is a triangle with a base c and height h. So the area of our triangle is going to be half the base times the height. So it's going to be half of c times h. So let's do that. The area of our triangle is going to be half the base, which is c times h. In our case, this is going to turn into half of c times the square root of a squared minus c squared plus a squared minus b squared over 2c, and that's all squared. Okay, so now we've got to get into converting all of this to Heron's formula. First thing we've got here is a half c outside the square root. So I'm going to stick that inside the square root. So if I have half c, or just c over 2, that's half c. What I'm going to do is square it. That'll give me c squared over 4. I'm going to stick that inside the square root symbol here, so that won't change anything then. So what I'm going to do is put c squared over 4 in there, multiplied by the a squared minus c squared plus a squared minus b squared over 2c squared. So all I've done is I have multiplied this by everything inside the square root here, but I've used this up here, c squared over 4, so I can get if I get the square root of c squared over 4, you're just back here again. And this remains square rooted if you like. So let's just push on again. Next thing I'm going to do is I'm just going to multiply this out. I'm going to multiply the c squared over 4 by a squared. I'm going to multiply the c squared over 4 by all of this here. So what I end up with here is c squared a squared over 4 minus c squared over 4 times c squared plus a squared minus b squared all over 2c squared. Okay. Now, next thing I'm going to do here is I'm just going to change this. I'll just put in our square root symbol first. I'm going to change this to ca over 2 all squared. You can see how that's the same. Ca squared is c squared a squared. 2 squared is just 4. Now, over here, I have c squared over 4 here. I'm just going to take the top of this, c squared plus a squared minus b squared, squared. So I've squared, what I've done here is squared the top, and I'm going to square the bottom. If you square the bottom part here, you'll get 4c squared. So that'll give me ca over 2 all squared minus, here now you can see you've got a c squared here and you've got a c squared here, and we end up with 4 times 4, which is 16. So I end up here with c squared plus a squared minus b squared all squared, and then on the bottom here I end up with 16. So let's push on again. So here we have the square root of ca over 2 all squared minus, now I'm going to convert this into an entire square again. So the top line squared would be c squared plus a squared minus b squared. The bottom will just become 4. So if you square the top, square the numerator, you'll end up with this. Square the bottom, you'll end up with 4 squared, which is 16. So you can see here what we've ended up with here is the square root of the difference of two squares. And if you remember, the difference of two squares is just the first term plus the second term times the first term minus the second term. So that's what I'm going to do now. So let's just do that. So the first term here is CA over 2 plus the second term here, which is C squared plus A squared minus B squared over 4. And then we're going to take the first term, which is CA over 2, subtract the second term, which is C squared plus A squared minus B squared, and that's over 4. So that's the difference of two squares. Okay, next thing I'm going to do is just add the fractions. So let's do that. So in the first bracket here, I have a common denominator of 4. So that'll give me 2CA on the top plus C squared plus A squared minus B squared. Over here, same kind of thing. I'm going to have a common denominator of 4. That'll give me 2CA up here. Now, here then I'm just going to end up with minus C squared plus A squared minus B squared. Okay, next line. Let's just see if we can simplify all of this. Now, if you look at this here, just the top line, the numerator from this fraction here, you have 2CA plus C squared plus A squared minus B squared. Now this part here, if we just take these three terms here, you can probably see here that that's just simply C plus A all squared. So C plus A all squared, or just C plus A times C plus A. If you multiply that out, you'll get C squared plus CA, or let's put AC here, AC plus A, C plus A squared. So that'll just give you C squared plus 2AC plus A squared. So, and that's what we have here. We have a C squared plus A squared plus 2AC. So we can just change that to C plus A all squared. So here we have C plus A all squared minus B squared. And then underneath here we have 4. Over here then we have the same kind of thing here. I'll just do it over here. We have this 2CA minus C squared minus A squared plus B squared. Now, if you take the this part here, we're going to take this part here, put the B squared first, minus the C squared minus the A squared plus the 2CA. We can rewrite that as B squared minus C squared plus A squared minus 2CA. You can see here that this will just become B squared minus, again, as we did up here, it's the same with these three terms here. What we end up with here is just simply C minus A all squared. So all of this numerator here will just convert to B squared minus bracket C minus A all squared. So let's just substitute that in here. So we have a B squared minus C minus A all squared, and that's all over 4. Okay. Now let's move on to the next line then. Okay, square root again. So what I'm going to do here now is just look at what we have in the numerators of both of these fractions. They're both, again, the difference of two terms squared. We have something squared minus b squared minus something squared here. So I'm going to expand those out. So really what you've ended up with here is c plus a, the first term, plus the second term, times the first term, c plus a, minus the second term. Again, all over 4. And same over here. So we have the first term, which is b, plus the second term, c minus a, times the first term, which is b, minus the second term, which is c minus a, over 4. I could put these in brackets here, but because I have the plus here, I didn't. But I'll put it in now because I have a bracket here as well. So that's that line. Okay, so what we have now is we have c plus, well, let me put them in order. We have a plus b plus c. That's these three here. I'm going to split this 4 up into two 2's. So I'm going to put that over 2. Okay, so what I'm going to do with this term here is add and subtract a 2b. So if I do that, I'll end up with c plus a plus 2b minus 2b minus b. And I'm going to put all of that over 2 as well. Now if I do something similar over here, what I've got here is b plus c minus a. So I'm going to add and subtract 2a. So I've got b plus c plus 2a minus 2a minus a. All of that again is over 2. And then finally over here, I'm going to add and subtract 2c. So I'm going to take b. This here, by the way, just becomes b minus c plus a. This part here, b minus c plus a. So what I'm going to do is add and subtract 2c. So it's going to be b plus a plus 2c minus 2c minus c. And all of that is going to be over 2 as well. Okay, so let's see what we've ended up with here. So again, big long square root here. So we have a plus b plus c over 2, which is what we want. A plus b plus c all over 2. That's perfect. Now here we have in our second bracket here, we've got a plus 2b minus b, which is plus b. So that will give me my a plus b plus c. So that's the a here, the c is here, and this plus 2b minus 1b gives me this b here. Now I'm going to put that over 2, and then subtract what's left then. Remember, I've used this 2b, I've used this b, so I'm left with a minus 2b here. So what I'm left with is a minus 2b over 2. So really what I've done here is I've taken this expression here, separated out into two separate fractions here, common denominator being 2. You can try this separately yourselves, add these two, you should end up with this anyway. Now, here, same thing again. I want the a plus b plus c over 2. So can I find that somewhere? Well, let's see. Well, we have plus 2a minus a. That'll give me my a here. I've got a plus b and a plus c, so that's it, and it's over 2. What am I left with? Well, I'm left with this minus 2a here, minus 2a. So let's just put that down here, minus 2a over 2. minus 2a over 2. Okay, and finally over here then I want the a plus b plus c over 2. So let's see if I can find that. Well, there's the a, there's the plus b. Now I want a c. Well, I have a plus 2c here, I have a minus c here, so that'll give me my c, and it leaves me with a minus 2c here. Minus 2c is left here. So I can just write down minus 2c over 2. Okay, so let's have a look at just sorting all this out. If I'll just write this in first. Remember what we said at the very beginning. S here is just going to be equal to the three sides added, a plus b plus c all over 2. So I'm going to replace a plus b plus c over 2 here with s. So you can see here we have this here is just going to become s. So that's my s here. This is going to be an s as well. This here is going to be s. I'm just going to put an s in there. And then it's going to be minus, well, that 2 there will cancel with that 2 there, and I'm left with b. Next one here, I've got this here. This again is just s. And then again, I've got this 2 cancelling with this 2 here, and I'm left with a. And then finally, I have another s here. So that's s minus. This 2 will cancel with this 2 here, and I'm left with c here. So that's really it. That's really it. That's Heron's formula derived. A little bit of tricky manipulation there, but nothing too difficult.